Okay, so I didn't have the time to open the presentation. One of you open it and can one of you open the presentation and I'll give him permission to share the screen.
Yeah, sure, I can open it.
Great. So
A second. Okay. I just need permission, Jordan.
yeah, I'm trying to, I'll just make you a host. Okay. Yeah. Okay, try now.
Can you see it?
Yes, great. Thanks.
Okay, so yeah, so it's divided to about the recitation and the quiz
Okay.
and the project and other.
Okay.
Okay.
So let's start with the so let's just follow the line. 1 minute, I'll try to join from my computer again. Okay, now it should work. Okay, I'll be back within less than 1 minute. I'm just using my laptop. So I'll be back within a minute. Okay, great. Sorry it took some time. Okay. So can you please zoom, Avia?
Okay.
And can you, okay, I think that, sorry, I logged you off. Ah, 1 minute, okay, the computer is doing problems. Avia, can you send the link here in the chat for the presentation?
Yeah, sure.
Thanks. I'm really, really, really sorry about all this mess. This is the reason why I wanted to do it at Sunday.
I sent it.
So, okay, so we are recording and we have the share screen. Great, okay. So about the recitation, sorry. So Araceli, I see that this is yours. And this is about how to calculate the Fano factor. And the instruction says the max STD def is the difference between max and min, but they are calculated differently. Okay, so right, okay, so Araceli, tell me if you, I didn't fully understand the question.
I just wanted to know because if you read the first sentence in the image, it says to calculate the variance, we look what is the difference between mean spike count and max spike count, and this is the maximum standard deviation.
Right.
So the minimum is 10 and then the maximum is 11. So the difference between these two is 1, right? Because 11 minus 10 is 1. And the sentence says that this difference should be the maximum standard deviation. But then when it's calculating it, it says variance equals, less than 0.5 squared. But
Right.
where does this 0.5 come from? Because the difference was 1, not 0.5.
So I think that was this the next line? Was there a calculation for the
Yes.
expectation?
Mm-hmm.
So that the expectation is 10.5, right?
Yes.
And I meant to write here, not that this is the maximum STD, that this can allow us to calculate the maximal STD. Okay, and what do you understand what is written here?
No,
Okay.
because I would
So-
say I would understand that the difference is the maximum standard deviation. That's what I don't get.
No, so it is not the maximal standard deviation. It's our way to calculate the maximal standard deviation. So what do I mean by that? So let's say that we have a bin of 100, okay? And let's say that one way to organize all these bins of 10s and 9 is that you have 10, 9, 10, 9, 10, 9, 10, 9. And then each time that you take 100, right, then the variance is 0. Do you understand why?
Mm-hmm.
Because each time you have the same 10, 9, 10, 9, 10, 9, and then you have the same number of spikes within each possible bin, okay?
Mm-hmm.
So this is the minimal variance. Now, what we can do is either use the minimal or the maximal. The maximal is that you have the biggest possible difference between the between two bins, so that one of them is only with 10s and the other is only with 9s. Is that clear?
Mm-hmm.
And then this is the maximal, this produces the maximal variance. And now we can calculate the variance. So how do we do that? So we have the minimal number of spike counts is 10 when you use the bin of 10, and the maximal spike count is 11, right?
Mm-hmm.
And then you can calculate the expectation, which is 10.5. And when you put it in the formula for variance, you get 0.5 square.
Okay.
So now we have a kind of the maximal possible limit of variance.
Mm-hmm.
And I think that I showed you two ways to calculate the CV and the Fanoff factor. And basically, when you have this kind of two different intervals, you can interleave them one with another, and then you have the minimal variance of 0. Or you can put them in one bin so that you have only the first kind of bin, and in the second you have only the second. And then this is the maximal possible variance.
Mm-hmm. Yes.
Okay. Great.
Thank you.
You're welcome. Okay, so another question from Araceli. So I see the formula for the probability of success says P of success is 1 minus beta. This is the integral, right? But so that means that we need to calculate the area under the curve, okay? This is what is written here. Is that clear, Araceli? Because every integral is in fact could be also translated into the area under the curve.
Yeah, so basically instead of using the explicit form of the integral, we're
Yeah.
using the trapezoid
Exactly.
area, right?
Right, exactly.
Yeah. Okay,
And
now
we
it's clear.
Yeah,
Mhm.
but if,
And
for example, we use this one, the red one, we can use the formula itself, right?
Yes. And I had the question, in the case that we have two values on the y-axis that correspond to the same value in the x-axis. So that doesn't have any area, right?
Right, right.
Perfect.
Just
Yeah.
put two dots which are overlapping.
Yeah,
Yes,
that's what I wanted to know. Yeah.
yes, it's a
Thank you.
good question.
Mhm.
Okay, and now I see that there are questions here about the quiz. Okay. So Avia, I see that you're the first one, and oh,
2 questions from me,
Uh,
yeah.
oh, and Ksenia, you wrote to Araceli that in the recitation
Yes, yes, yes,
there are more explicit calculations for that.
yes.
Thanks. Okay, so you were asking about, yeah, quiz 4. So that we have the hazard function of the dangerous dwarf is given below. And we have, this is the hazard function, and we have two possible ISIs, is either at 100 or at 500. And we can see by the relation between them that the probability for each one is 0.5, right, Avia?
Yes, okay.
Great. So the TIH is like the TIH in the recitations that we were doing, like the example that Araceli just showed, that you have equal possible distribution between two possible ISIs, okay? And then if the sampling rate is 1,000 samples, what is the autocorrelation value at the time lag of 500? Okay, so, right. So the calculation is as follows. So if you want to have, so the ISIs are either 100 or 500. Therefore, what are all the possible time lags that we have for the autocorrelation?
I guess 100 and 500.
And 500, right.
Yeah,
But you might say that you could also have 600,
600 and more.
right, and so on. Good. So we understand what are the possible time lags. And when we think about these time lags, we believe that they are interleaved, right? It's not like you have 1 second that all of them are 100 and in the other it's 500. We believe that they are interleaved. So it's 100, 500, 100, 500. Now let's say, let's first count how many spikes do we have within 1 second. So we have 1 at 100, and then we wait 500 milliseconds, and another one at 600, and then another one at 700, right? And then we wait another 500 milliseconds, and it's outside the second. It's already at 1.2. Great. So we have 3 spikes. Therefore, we can say that our, if we count like this, we can say that our rate function is 3 spikes per second, right?
Okay, so the way to answer this question is just try to figure out how many spikes we have within 1 second.
Yes.
Okay, I understand.
But the spikes have to be like, if I have 100 and 500, they have to be like 100, 500, 100, like it has to be
Yeah,
like that.
interleaved. Yeah,
Interleaved.
But actually there are more options, right? But we assume.
Yeah, we can assume that. You are right, Ella, that it is not explicit, but you know, if you even write your calculation different, for example, if you write the calculation that you have the all the 100s at the first, second, and the other, and in the second one, it's only the 500s. And then you calculate the autocorrelation, you will have full points, okay? Because nobody told you how they're organized. But I thought that this is given from an exam of Izal. So I thought that it's kind of, for me, it looked like it should be interleaved. So then you calculate that there are 3 spikes per second, and the probability for 2 spikes to be at the distance of 500 when they are interleaved, it's only for half of the spikes, therefore it's half of the rate. Okay.
But here the question did ask about, oh, okay, never mind. Because I saw rate and I thought it was also confusing to me.
Yeah,
Okay, but basically it's how many spikes were in that time. Okay.
exactly. Yeah. So half of the spikes when you shift for 500 milliseconds, half of the spikes will meet another spike. And these are only the spikes that are interleaved within 500 milliseconds.
Okay.
Okay.
Okay, thank you.
Thank you.
So basically here, we chose 3 spikes per second
Yeah.
just because the time interval goes from 0 to 600, and from 0 to 600 the spike train has 3 spikes.
Exactly. So this
Okay.
is our,
Okay, perfect.
if we believe that this is regular, I'm thinking now to myself, how could we solve it if we say, for example, in the first 1 second, it's only the 100s, and then in the second, it's 500s. And then what would be the firing rate, the mean firing rate? So we have 10 spikes per second in the first second, and in the second one, it's 2. So it's the average between them, right? So it's 6 spikes per second, and then the answer would be 3, right? No, because we have also the second with the 100, and then you have more. It's not only half. Do you understand my answer?
No, sorry.
Okay. I'm just kind of doing that in my head, and I didn't explain it. So 1 minute. I'll use here. I'll do the following. So if we say to ourselves that these spikes are not interleaved, then we want to make just a bit more confusing life to ourselves. I'm just saying that just for the sport. So let's say that we have in the first second, we have a spike within each 100 milliseconds. We have here. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have 1 here and 1 here, right? Now we say that over here we have 2 spikes per second, and here it's 10 spikes per second. So that the average between 2 and 10 is 6 spikes per second, right?
Yes.
But that's in not in 1000 what was the time that we were asked
Yeah,
to?
I was just wondering also.
Oh, okay.
They don't say what is the time lapse, what is the
Oh.
duration of the recording.
Okay.
So now we need to count all the spikes which have a possible ISI of any order or possible time lag of 500. So let's see, we have this one and this one, this is 1. And then we have this one and this one, this is 2. And we have this one and 100, 200, 300, and this one, right? And this one and this one. this one, and this one, this one, and this one, and this one, and this one. So we have here 5 and here 2. So it's 7 counts, right? Out of all possible time lags. Out of all all possible spikes. So so this is not half. This is what I meant. That first I said, okay, if this one is 6, then half of it is 3. But then it's not half because you need also to count this, right? So you can go on with this kind of a nice question. But now I go back to the hazard function. Please note that if these spikes are not interleaved with each other, then it's not like it's not the hazard function. In the hazard function, it says that the probability of 100 is half, right? But
Mhm.
if they are organized in this way, then it's not
Oh,
the
it's not
probability
half.
here, it's not half. So you need to add more seconds of this one so that they will have the same number of eyes of 500 and 100. And you can go on with it and you can try to solve it. I'm not sure that it will reduce something different. Okay. But you can try it. Like it's a good exercise for the exam.
Yeah, then can I ask you something just about the final? Can you repeat how we went from 3 to 1.5? I understand we divide
Yeah.
by 2, but I don't. Yeah.
So let's say that you have here the spike train and it looks like, let's first erase it all. No, not like this. Right. So we have the spike train. And then we have at 0 and at 100. And another one at 600. And another one at 700. Right? And then another one at 100 and 1,200, right? And then you first, when you want to ask yourself, given the rate, you know that if I take this spike train, right, and I shift it by 500 milliseconds to the left, I need to ask myself how many spikes here will meet another spike here. So we know that the one from 100 will meet the one from the 600, right? And the one from the 700 will meet the one from the 1200, right? This is for this example.
Okay.
But for the second, if I will go on here and I will also have the spikes here, this one is 1300 and then it's 1100, right? So for this one, we will have only the 1800 and the 1300 that they will meet, right? When you shift, if I shift here, so the 1800 will be here and 1300 will be here. So I can see that within 2 seconds, I have this pair, and this pair, right? So I have 3 pairs within 2 seconds. So within 1 second, I have 1.5 pair. Therefore, the rate is 1.5.
And the reason why I know that I should count it for 2 seconds is I ask myself how many 500 lags fit in.
Yeah, so the way I do it, and which I think this is the easiest way, is that I just count what is my rate, right? And the rate is 3 spikes per 1 second. And then I say, if only half of them are 500 millisecond ISI, therefore the shift will make only half of the pairs each time.
Mm-hmm.
So it will be half of the rate. And the rate is the rate is 3, therefore half of it is 1.5.
Okay, thank you so much.
And then
How did we find out that for the half of the spikes, the EC is 500?
Excuse me, Xenia, how did we find that?
That for half of the spikes, the EC is 500.
Oh, so this is, we understood it, we're assuming it from the hazard function, because in the hazard function, we see that we have an ISI of half for the 100, and then the rest is for the 500. Therefore, the PDF is equally either 100 and 500. And the easiest way to solve this is by organizing them in an interleaved way, so that you have 100, 500, 100, 500, right? Instead
Yes.
of what we saw that you have in the first second only 100s, and then in the second and third and 4 and 5 and 6 seconds you have 500s, and then the calculation is much harder.
Okay, thank you.
So you just assume the easiest way to solve when you solve it analytically. Okay. Next.
Yarden, here my question would be, how do we know when to stop counting? Because we use 2 seconds, but what if we only did 1 second and the answer was 2 spikes?
Yeah, so I think the right thing to do is to look for the full period, right? Because maybe also 2 seconds is not enough. So if I want to be really sure, for example, in the solutions that I sent you, you can see that I'm looking for what is the full period for the calculation. And then sometimes it's 50, sometimes it's 400. And maybe in this one, it should have been even longer, because I'm looking at the exact second that I have a spike within exactly at the beginning of the second. So probably the right thing to do is just go on with the plot and calculate it more accurately. But the main idea is that I'm looking for the pattern. Okay, anyhow, the reason that I always like to plot the spike strengths to myself is that I can visualize these shiftings, or I can really count them. So I think that the most important thing when you solve autocorrelation and cross correlation is first, if possible, try to draw the spike train, and if it is impossible, draw the firing rate. And then start all of these shiftings. For example, in a Poisson neuron, it's impossible to plot the spike trains. And then you can plot just the firing rates, and the firing rates are just doing about the same things in relation to each other. Okay. I understand the first part of the answer, but didn't understand why the cross correlation of A to B causes peaks. So we have the 2 neurons A to B, which receive a common inhibitory input from a terned neuron. The inhibition period is different between the 2 neurons. Therefore, for A, the inhibition is longer, and for B, it is shorter.
Wait,
So,
but how did you said, okay, I just understood that it's different, but not that one is longer than the other, but maybe it doesn't matter, I don't know.
so the reason that one of them,
It doesn't matter which, right?
yeah, the reason
Okay.
for the peaks is the fact that they have this different duration of inhibition. Do you understand, Avia? So that the first one already finished the inhibition, and now there is an increase in its firing rate,
Mhm.
while the other one is still during this period of inhibition.
Inhibition.
Therefore, the relation between them will be as if if one causes peak to the other. Okay. So this is the only reason.
Okay, but what do you say that one causes peak to the other? The calculation is right. It's just, I guess this is because I don't really understand the calculation of cross correlation. But you say that because of the difference in time of inhibition, so we will always
Exactly.
get peaks.
So it might look as if one excites the other, but it's not really that it excites it. It's only that its inhibition is shorter.
Okay, I see.
So it looks like an elevation in the number of spikes.
Okay. Thank you.
Aksania, it looks like you're raising your hand.
Now I'm thinking. Sorry.
Okay, project. Great. Okay, so average, Ksenia, okay. Average the Fano factor and CV for the 100 simulation. No need to do the 100 simulations. I'm sorry. Just do it for one. It's at the beginning when I wrote the question, I wanted you to create 100 simulations and then calculate and show the distribution and so on. Then I kind of thought to myself, okay, this is just too much. So leave it, okay?
Okay.
So it's a typo, that's it. Here, project 2, section 1, question E. I don't remember all of the questions by heart.
This is the question where we need to calculate cross correlation, and I was just wondering if we need to normalize it, just like for auto correlation.
Yeah, I think the best thing is to use cross correlation, which is normalized to rate. Yes, if possible.
Okay.
Rate or probability, it doesn't matter. But yes, normalized. Now, cross correlation between the presented neuron and each of the other neurons. In the cross correlation of two neurons with different spiking rates, do we expect to see high correlation at lag 0? No, there shouldn't be one, Ksenia.
Yeah, no, this is my question.
Sorry.
Yeah, exactly. I'm so confused as to why I'm getting that. I thought maybe because they start the recording at the same time, like they're both 90 seconds. But yeah, just wanted to make sure it doesn't make sense that I'm getting a peak at 0. So
no, it shouldn't. And I can say besides, Rin, that I would suspect that there is a bin that you accidentally wrote that there must be a spike. For example, that in the first bin, you kind of said, okay, here it begins, there is a spike here, and from here start. Or
okay.
something like that. When you created the Poisson simulation.
I'll check what I did.
Yeah.
Okay, I'll check if I have time 0 spikes for all of them. Thank you.
You're welcome. Okay. Okay, Araceli. So based on your simulation, calculate and plot the autocorrelation. And you ask why to use max time lag as 100 milliseconds if the signal is 90 seconds. So the maximal time lag, Araceli, if you want to be sure, you can of course take even longer time lag, but the time lag has nothing to do with the duration of the recording. It's just all the possible shifts that you can do. So plus minus 100, as far as I remember, it's about the the region of autocorrelation which is relevant. As far as I remember, you don't see something besides, it just stays permanent because these are Poisson neuron. But if you see something different, then you can report on it. Please note that as the time lag goes bigger, it becomes more noisier and less accurate. Okay, so maybe also for you, and this is only due to the fact that this is that this is a finite sampling. Okay, I hope
Yes.
that I answered.
Yes, thank you.
Okay, using the main experiment data, calculate the STA of the signal train pair using plus minus 500 millisecond window. Yeah, so plus minus, that means that you need to have 500 milliseconds before and 500 milliseconds after. Yes, and this is symmetric around the time of 0. Yes. Ah, is that it? Oh, and this is other. Okay. No question over here. Okay, that was really nice. I must say that I enjoyed the presentation.
I have another question, but it's about this quiz. The one that is for this week.
You can ask, it's okay.
Okay, so the penultimate question asks you about.
Do you want to share the screen?
Yes, sure. Oh, but
Do you want me to open it?
Okay, let me see if I can.
No, it's okay. I'll just open it.
Okay.
I use too many Google Forms. And it's this one, right?
Yes.
It's this
Uh-huh.
one.
So I'm wondering about the penultimate question.
1 minute. So we'll just open it. So I want to preview it. Yes. Okay. Which ones?
About the ROC curve.
Yes.
Yeah, that one. Yes. So here it asks you to identify the best electrode. And I was wondering if we should do it just by visualizing the probability graph, because if I do this, I get a different result than calculating the probability of success. Because in the last question, it asks the probability of success of one of the electrodes, but I calculated for both just to compare. And that's why I'm wondering about the question before, because I get two results depending on the method. If I do only the probability graph, I get one result, but if I calculate the probability of success, I get another one.
No, so here you need to do the probability of success. And by the way, there is a very high chance that you can just take these two vectors into Python in one of the libraries and just write the area under the raw curve of all of these matrices. Okay. For example, the area under rock for this one and the area under rock for this one. And then this will help you just to determine what is the right question, what is the right answer here. If you want to do it more analytically, as would be expected in the exam, so you can also try to calculate the ROC yourself. It is not really hard. We've seen it at the class today.
Yeah.
And here, for success, you need to use the formula from the recitation notes.
Yeah, perfect.
Okay.
So if we calculate the area under the curve with the Python library, the closest to 1, it's better.
Yes, exactly.
Perfect. Thank you so much.
You're welcome. Okay. More questions? Okay. So see you on Sunday. And please write me emails. I'll do my best to answer ASAP. And good luck.
Thank you so
Thank
much.
you. Bye.
Have a nice
Thank
week.
you.
Bye.
Bye bye.
Bye.